there too.
So after we did this, the next step was to create the table, and so the independent variable was the pool number, and then the dependent variable was the ratio of the number of border tiles to the number of total tiles. And so for pool number 1, the ratio of border tiles to total tiles is 8 to 9. For pool number 2, the ratio of border tiles to total tiles is 12 to 16. For pool 3, the ratio of border tiles to total tiles is 16 border tiles to 25 total tiles. For pool 4, there are 20 border tiles to 36 total tiles, and for pool 5, there are 24 border tiles to 49 total tiles.
And they converted those to decimals because most science people prefer decimals. I don't. For this one, I'm looking at the fractions. Okay, go ahead.
So for more of our graphing purposes, to divide the ratio and get a decimal to be able to graph it easier. So we noticed that when, again, our independent variable being the pool number, and our dependent being our ratio of border tiles to total tiles, we have a 1, well, 8800 is very close to 1, so and then it does decrease in a non-linear manner.
That's it.
And then lastly, we came up with the equation, the explicit equation for the border tiles, and we put it over the explicit equation for the total number of tiles.
Which took a while for us to figure out the
explicit rule?
yes, the rule.
Okay. So looking at the table, would you expect this to be linear? Why not? To me, looking at the fractions makes it so plain. Look at 8 over 9. That is so close to 1. She even said it. So close to 1. And then I look down to 24 over 49. That is almost half, about half. So it doesn't appear that the rate of change is constant, just eyeballing the fractions, right? Which is what you want your kids to be able to do. Eyeball it and see what they think, and then they can check it out later. So we could find the finite differences in there. Using the decimals in this case would be easier for that. And is there a constant rate of change?
No, there was not.
No, there's not. And of course, there's some rounding involved. So that made this even more difficult. If you went out to the second level, would it have a constant rate of change? Did y'all go that far, Pam?
No, well,
Michelle?
we did not, but
We talked
actually you
about
did. We
that.
talked about it because that's how and coming up with the other groups, why we have the squared piece of the fraction here on the in the denominator. So, well, yes. So the denominator would have had a.
I knew that when you, what was it? It was 9, 16, 25.
So in the denominator, it did.
So we increased by 7, increased by 9, and then we went the second level, just like they were talking about.
Yeah, okay, just because the denominators
Right,
of each
it only
ratio.
had- yes.
Okay,
And I knew that when you go to that second level, it meant squared,
yeah.
but we were trying to figure out what is squared. Where does the square go? Does the square go with the x? Does it go with the binomial? So,
And I guess when we get to a entire ratio, no, they wouldn't. But we tried to look at the numerator did have a recursive 4. It changed by 4 units, from 8 to 12 to 16 to 20. Then we tried the denominator, and we found the second level.
Okay,
Again, is why we get the squared.
yeah,
I can't think of the word, but yes. So,
explicit.
but as the entire ratio, I don't think it does. Well, it's kinda hard to explain, yeah.
It may, yes, sir.
Will your line, as it descends, cross the x-axis?
No, it will not.
Okay.
It will get,
So if your line had a constant rate of change, would it cross the x-axis?
if a constant rate of change is, say what?
Y'all agree?
That's not a third grader.
We haven't.
They're not third, they're
This is
obviously,
not a
yeah.
third grade problem.
No.
So do y'all agree? If it has a constant rate of change and it's decreasing now, it's the first one we've had that's decreasing, right? I don't remember, okay. If this continued to decrease in a constant rate of change, which means it's linear, would it cross the x-axis?
Yes.
If we had negative numbers, you know. Okay, all right. So it's a curve, is this curve going to cross the x-axis? No. Is it going to approach it as much as the other one did that we were talking about?
Yes.
Well,
It might take a while, but it might get pretty close to it. I'm not sure on this one. I didn't carry it out past 10 when I was working it, so I'm 10 pools, so I'm not real sure there.
wait. Okay, never mind. I got it. Never mind.
Okay. So, we decided it's not linear, right?
And not recursive.
And, not a constant rate of change on the first level, okay? Is it proportional? Are you sure?
Yep.
Why are you so sure when you weren't sure on another one?
Well, cause now I
Because
know.
now I know the process.
And it's not linear, not linear, and it will not go through the origin. So you can tell by the table, constant rate of change, you can tell by the graph, and
Well, I guess this one
you
kind
can
of
tell
led,
by the rule.
to that realization more easily than I think this group did. Because when we divided to get the decimal,
Mm-hmm.
if they were all the same decimal,
Yeah,
then it would have shown a proportional relationship.
yeah, that's, well, not the same decimal, but a proportional decimal, yeah. Cause you wouldn't have
The same
one
difference.
with 88 hundredths and then two with 88 hundredths.
That reminded me of something.
Wouldn't be the same. Cause if you have one with 88 hundredths and two with 88 hundredths, now let's think about that.
If I divide,
So we have one with 88 hundredths, can you see? And two with 88 hundredths, and three with 88 hundredths. What's gonna happen to the line?
Based on you be comfortable.
It's gonna be horizontal, horizon, it's gonna be horizontal, right? Still a function, but horizontal, not a curve, isn't it?
Okay, you said 8800, so that triggered my brain. Sorry if I hurt anybody else's brain right now or whatever. Not really. On STAR, we are not allowed to say that when we do oral administration anymore.
Not
We
saying
also-
what?
We cannot say 8800s. We cannot say divide by or out of. We have to say 1/8 or whatever. So how would we address that
You
in
can't
the future?
quantify it.
Exactly. So when we do our lesson, so to say,
I
and
would say
we've
both.
gotten to the point of 8800s, with me, I've gotten to that point now.
I would say both.
Okay.
What I used to do with my algebra
So now I'm gonna
students,
switch back to my kids like 2 weeks before STAR.
yeah, just say both. When I was working with my algebra 1 kiddos, and we were talking about dependent, independent. And y'all have already used the words, one is dependent on, or one is determined by,
Yes.
to indicate dependent, independent. If they said independent, I would say is determined by. And if they said is determined by, I would say independent. So that they heard both
Okay.
every time. And sometimes they would, whoever said independent and I said is determined by, they would stop and say, yeah, it's determined by. And I said, yeah, independent, you know, and I would switch on them.
So just get that
So
verbal
that they,
back in,
yeah,
back
so
in
they
play.
heard it all the time.
Cause y'all like beat it into me since mixed, and I'm like,
I know, but if STAR changes things, we have to
okay.
adjust to their way of students. Yes, ma'am.
So, I think what she was saying, what I was hearing,
It's twice as more than you said you think.
She's thinking
I
today.
think a lot.
I'm impressed.
I woke up time this morning. Okay, so what I think you were saying when you said that it would be 8,800s,
Yes.
if you divided them, is because if you divided, say our data was 8/9, 16/18, my math stops there, okay? So when I take 8 divided by 9 is 8,800s. When I take 16 divided by 18, it would be 8,800s. So that's what she's saying, but the fractions are changing, but the decimals, when we actually divide it, they would all be the same if it were changing at a constant rate.
And the fractions would
But
look
the
different,
fractions would
but they
look
would be
different, but
equivalent.
the
Right.
decimals
So that's what I
would
was,
be,
I guess,
that's
yeah, I
where
was
she
like
was
trying to,
confused.
And keep in mind that they've rounded this 8,800s because
it would
that's,
have been a repeating decimal.
yes, it's a repeating decimal.
Okay, well then now you got me really confused. So was I correct in saying that when I divided, if they were proportional, they would have all equaled 8,800?
They would have had the same decimal, when she told me she actually divided them out.
Well, the ratio is comparing this number to this number,
Yes.
not these two. Okay, if these two were 88 all the time, that's different than comparing this number to this number. If you put 1/8/9 to simplify that, what would you get? Compound fraction people, not 8.
Oh,
If you
okay,
put
got you.
2/12/16.
I forgot about the pull number, because then
Yeah.
that's the relationship.
Yeah, that's what you were, yeah. Okay. Okay, any other thoughts on this one? Did they answer all of the questions? I want you to look at their explicit rule. That is a very difficult explicit rule to come up with. What grade level would that be a part
Oh
of?
my god.
Which grade level do you teach?
That's not 7.
Eight.
Y'all are not listening. Is it algebra 1?
Eighth
Is
grade?
it also algebra,
Well, it's like what, pre-AP, 8th grade?
Yes, at 8th grade algebra. Is it algebra 2? Is it also done in pre-cal? That expression?
Coming up with it?
Yeah.
No.
No, so algebra 1, algebra 2, which is not 3rd grade. Do it in calculus, she said. Not pre-cal, but calculus. That's the teacher for us. By the way, actually, calculus did not have teach when I taught. It was the AP exam. And that's it, that's what we went by. No teach for calculus. So my job at one point in time was to create benchmark exams for every math course, every grade level, K through whatever, and every science course and level, K through seniors, except calculus, because they didn't have teaks and I couldn't create those benchmarks. And that would have been a really fun test to make. I didn't get that. Anyway, thank you, ladies. Very nicely done. And that was D. So E.
Go to it, Matthew, since you made that.
Alrighty, so, like this,
Yeah. I'll hold it every job. Go to the front.
so with everybody else, we created our 5 pools first and then had them draw on our poster. And then we created a table, and our table looks different than yours. We had, the ratio of actual pool tiles to actual, total tiles, but we had it broken up into 2 pieces. So the ratio is still the number of pool to pool tiles over total tiles. And when we were looking at this, we noticed that this was not a proportion because the ratios are not equivalent.
Okay. So that means it's not gonna be something else.
It's not going to be linear.
Okay.
Then we came down to the graph. And one of my beautiful science minds was doing the graph. And in discussion with the graph, they wanted to change it and I told them no.
Okay, so tell me what they have first,
What they have on our independent variable is the total number of tiles.
okay?
And on the dependent variable, the actual pool tiles. So the graph was looking at the total tiles versus the total pool tiles. Instead of the pool number versus the ratio of pool tiles to total
So they
tiles.
reverse the X and the Y values.
They reverse the X and Y values.
And then they wanted to change it. Why did they want to change it?
Because they wanted to put the X value of pool tiles and the Y value of total tiles, and I told them no.
Why?
Because some kids will actually graph this way, and it's an example of how other students will graph. And then we can have a discussion about which one is the actual independent variable, which one is the actual dependent variable.
Which is a very rich discussion because kids sometimes don't realize which is the dependent and which is the independent. I cannot talk. Because in some functions, it doesn't matter. Because sometimes the number of eyes depends on the number of dogs, but sometimes the number of dogs depends on the number of eyes. It's depending on how you look at that problem. I use that word dependent again. So, when you switch in the X and the Y, it could work in some cases, right? Nobody else did that. The science person is the one that drew that. So part of the reason for that is she may not have realized what was dependent, independent, which I doubt. But in science, they switch things around all the time. Sometimes their numbers will go smaller in value as you go up the y-axis and smaller in value as you go to the right on the x-axis. Sometimes the positive numbers go down and the negative numbers go up. The science graphs are just weird. And the math graphs are all the same. You know, you have a coordinate grid. Positive numbers on the x-axis are always to the right, and positive numbers on the y-axis are always up. Not so with science. Not so with science. They fit it to fit their data the best way that will illustrate what they're trying to illustrate with their data. Okay? I'm not saying they're wrong because sometimes their graphs have, I'm thinking of that Herzog graph.
Russell.
Yes, and that one is totally messed up
Backwards.
for a math person.
Yes.
But I understand why they did it. Okay? So that's a discussion. If a kid group does that like that, then you have to have this discussion about what is truly dependent on what. So is the pool number truly independent and the number of tiles truly dependent? No. In this situation. No.
Depends on what is the, because in this problem, the pool number equals the actual number of tiles, the pool, the actual number of area tiles the pool encompasses, right? So if the number of the pool gives you the area of the pool, then yes, that border is dependent upon the number of the pool.
So in this particular exercise, I did intend for y'all to use the pool number as the dependent variable because of the way I stated the question. See the way I stated the question? If you could find the pool number by knowing any of those other things, could you find the pool number if you knew the number of tiles in the border? These are still square, they're still square.
Yeah,
You could. Could you find the pool number if you knew the number of border tiles over the number of total tiles?
yes, that would be easier.
You could, because of the total tiles.
Right.
That would be very easy. So in this particular case, it could be switched, but that was not my intent, but it could be, and there's some cases where it can be. I can't think of one right now, but there are some cases where it can be, okay? Any other questions? Thank y'all for leaving that like that, because that really helped a discussion. They did that on purpose just so we could have this discussion, right?
Yes,
No, we did it because science minds looked at the graph piece of paper that we borrowed off the front table. And to match our data, we needed that many spaces, so that's how we took out that many spaces. Then we're like, oh,
Oh.
But it was,
this is a marginal helper.
they were forced to keep it that way.
Yes, because the Grinch wouldn't let us change it.
Yeah, thank you, Grinch.
You're my real ringtone, you will know.
You're absolutely right, Grinch. It caused a great discussion. Pam?
Oh, one cool thing that Kim showed me that she learned in school is how to place, where do you place your independent and your dependent on the graph. And so she held up her hand like this, and I'm like, what are you doing? And she goes, these depend on this to pick something up. I was like, really? That is so cool. You know, so I'm gonna show my kids that, you know.
And that
things
would kill
depend
the
on
science
this.
guy.
Oh, what's
So good, yeah, you can prove that by taking their. You have a question, Whitney?
I just asked what their function is.
Your function?
Function, well, you're looking at taking independent parts of this problem. We came up with a bunch of different functions, but our overall function is n squared over n plus 2 in parentheses squared. So the number of pool tiles over the pool border will give you the pool number.
Okay. So, is it quadratic?
Yes. No,
Because n
because it
squared
has n squared.
over,
It has a square over a square.
okay, so, and they can't be canceled
No, they cannot.
because one's in a quantity.
Right.
So, we know right away from that it is not linear.
And if you can see the dots, they appear to be in a straight line. It's because our data is so spread out, but they are not.
Yeah,
They actually,
you really need more data.
yeah, Melissa actually took a piece of paper and tried to touch all the dots in a line, and she didn't.
She
Because
cannot.
we were having the discussion that it would form a straight line, so I just got one of the dots and connected to the other dot, and I'm like, can you see all the dots? She's like, no, I'm like,
Yeah, so it is not linear, yeah.
So, I mean, yes, I'm a math teacher. I had this question I asked you earlier, Ashley. It makes it quadratic because Brandon had asked if our equation is quadratic, which we'll go over just a little bit, but like, it's quadratic if it's divided by n or by a squared. How does it make it?
If there's a
It's-
square in
it's
it
a
anyway.
square.
So it's a square anywhere. Okay, so you were.
Well, no, I can't, no, you're, no, I said that wrong. It's a, it's not linear, but it's not it is quadratic, but it's not, I'm thinking parabola, it's not necessarily a parabola.
Okay, yes, I understand that. Okay, I got that part. But so it's quadratic as long as it's square. There's a square in there. It's just not.
Cause that, actually, you wanna handle this?
Yeah.
Yeah, 'cause I asked earlier. And that's
So
what I got.
not necessarily, I mean, generally,
That's what
it,
you should
if
say.
you have something squared, yes, that is generally quadratic. But it gets a little bit hazy when you have two things divided by each other that are also squared.
Okay.
So when you look at a data table and you're trying to determine is it linear, quadratic, or exponential, that's when you start looking at the differences of your data.
Oh.
So if we're taking the
shape.
ratio of 1/9, comparing that to 4/16, comparing that to 9/25, and you do your first order of differences and they're the same,
Okay.
then it's linear. So that's what we saw on this one. This was a first order difference because we saw that their border tiles were increasing by 4. So this is why this one was linear. When we looked at which one? Yes.
That one, 3, 4,
This one,
9.
that's a second order.
Okay.
So that means
Second
that's
order of
differences.
finite.
So that would be x squared, that would be quadratic. If it's exponential, then you have a ratio that you're multiplying by one of your values. So if you could find a common rate that you're multiplying by each of your values, then that would be exponential.
Like exponential growth,
Yeah.
exponential decay.
Okay.
And then there's
Now I feel
logistic,
better.
yeah. The word quad, quad means what? Four, what has 4 equal sides?
Square.
So that, that all fits together, that's where those names, mathematics names things logically.
Are you saying science doesn't?
I'm not saying it. Anyway, so can you tell me the reason why some of these elements on Melissa's shirt are named what they are?
Way to do that. What's TE?
Who knows why they're named that way? Some
Tellurium.
names
It is
some whoever.
tellurium. Yeah, sure, let's go with that.
Pythagorean theorem is named the Pythagorean theorem because Mr. Pythagoras has a proof of it. Okay? Cuisenaire rods are named Cuisenaire rods because they were developed by Mr. Cuisenaire, who happened to be Belgian. We're logical. Anyway, there was another comment we were going to make about y'all's that I said.
So we looked at or
We-
the science people looked at the rate, how our pool tiles are changing.
This is important.
So, do you guys wanna explain your thinking?
Okay, so I looked at the first one and I had one over, and then I put it over the next one and I saw there were 3, and I put 4, and I saw they were adding more. They just kept doing the L. They kept
Can you
adding.
see what she's doing? She has the squares and then Brandon doesn't, so.
Okay, so she had
I view it
Like, take a pen and circle what she's doing,
Or just draw it on the board.
or just draw it on the board.
I don't wanna do it on my paper.
Draw on someone else.
put it on the,
Not what
We can move ours.
on the board.
You have
Then
permission
that's
to move yours.
old school stuff goes up.
Pretend that I can actually draw this.
Looks like my drawing.
Alright, so I took this middle one, and then I
Wait, this middle what?
this middle tile,
Which represents water.
the water, and then I put it over. I kept putting the shapes over each other. And every time I put the shapes over each other, I do it, I'd get the L, and I'll get another L. So I put the 4 over here, and then I put this one, and then I get another L. This one, and I get another L, and then I added the other, counted them, and
Not actually nailed it upside down nail.
I counted the tiles that were added.
right angle.
And I tried to find the relationship between them, and that's when I went out to the second one, and then I found that there was 2. And that's how we came up
She
with.
was taking the area, the previous area.
Okay.
So the area from the first pool,
Draw
Of
the
water.
next level there. Go ahead,
Okay.
Tim.
and then
Oh, that's so
take the area from the first pool and added it to the second pool. So it would cover one, if you look up there on, the area of the first pool would cover one of the blue tiles. So then how many blue tiles were added to create that whole area? It would be 3 blue tiles.
For that one.
So here's the one
One.
pool tile, that's the existing pool tile, she placed over it and counted what was
That's
left
the same
over.
thing that's written.
3.
And then
Then
it
she
would be
took
5.
this,
and then
That
7.
complete
moved it
area.
over and counted what was left over.
And that's how I came up with L, countable.
She started coming up with differences, and to get a constant rate, we had to go to the second level and find the differences.
There's a square in there somewhere.
And we had Melissa
Okay, well, the fast
who
one like
looked
that.
at it and just said,
So I looked
The
at the
area is
picture and
just-
I'm like, I got this. It's being squared. So the pool, however many columns or rows, I decided to go columns. So I had 1 column, 1 squared is 1. I have 2 in a column, 2 squared is 4. 3 in the column, 3 squared is 9, and there's 9. So it's squared. Done.
So we've seen that before in some other, problems. That did not have this ratio as your second term. Okay, questions? So not proportional, not linear. It is quadratic, it's not quadratic, whatever. It's not quadratic, but it does have a square in it. Okay? Any other questions? Okay, nicely done. And that would be,
yes, now we have to go back to C.
let's go back to C.
Yeah, we might need to do F2.
So C is over there.
Oh, we're seeing. Sorry. Go ahead, Brandon.
Alright, so we looked at C. We're comparing the option, the pool number to the border
Yes.
and the total tiles.
Right, total number of tiles.
Total number of tiles. So we saw some different patterns here. We a total of 9 tiles total in the first, 16 in the second one, 25 in the third one, 36 in the fourth one, and then 49 in our fifth one.
All we had to do was compare the total to the
Right.
stage. To the pool number stage. That's what our job was to do. And then we created the table to represent our drawing or our creations that Dr. Browning started us with. And we saw that in the first pool stage, which we labeled as N.
Right.
What is your name?
Brianna.
Brianna was the superstar of this entire thing since the rest of us are math. So, which one do you want to do after that? this
I
one.
can do this one.
Okay.
'Cause I was the one.
Yeah.
Okay,
She was
So-
tortured slightly.
so here we looked at the number of pools, obviously. So pool 1, pool 2, pool 3, pool 4, and pool 5. And then we looked over at the number of tiles that was in each pool. And first I counted each one, and then I realized that, like here, this was a 3 by 3. So I said, okay, 3 times 3. And then it was 4 times 4, and 5 times 5, 6 times 6, 7 times 7. And then I realized that the number, I don't know if I'm going to say this right, I can't remember. So the number, like, of the tiles, like, I guess across was being squared, squared. So it would be like 3 by 3, right? And that gives you the total number of tiles. Okay. And then I realized, like, as we're coming down here, okay, that we said that this was going to be the number of pools. So as we were figuring out our function, it was number of pools, and then it was saying, like, okay, well, pool number 1 was, I guess, 3 tiles across, so it was 3. So 1, how many tiles were added to that was 2. So that's where I came up with 2. So every time, so it's like 2. Well, this one had 4 across, so that was 2 again. Okay, and then.
It's okay. This is what she was saying. She was saying that she first found the change or the difference, but at a level of, okay, we have a width or length, whichever one you consider it as, the first number of tiles. There's 3 of them in the first one. So she found the relationship of how to make the 9, the 16.
In a row?
Sorry, in a row, yes.
Yeah.
Or in a column. She figured out how to get the 9, the 16, the 25. And she found a relationship like, okay, well, it's the number in a row or the number in a column. And then we had to ask her, okay, well, our job is to compare or define the relationship between the pool number and the total number of tiles. So we made her, or not made her, but we asked her to show the relationship between, well, if she was getting 3 by 3, or 3 times 3, or 3 squared, we asked her, well, okay, well, how did we get this 3 in relationship to the pool number or the stage number? And that's when she started playing with them and figuring out, oh, I'm adding 2 to it. And she saw this just for the first one. And then we asked her, okay, we'll continue to see if it was consistent throughout. And then she did the, oh my goodness, and then got really excited, so we all smiled for her. Is she figured out, well, if I'm doing 4 times 4, or 4 squared, we got her to that point, what did I do to my 2 to get to the 4? So she noticed again, I'm adding 2 to the pool number or the stage number in which we started out with. So she discovered the relationship between, or the explicit rule between the number of pool and the total number of tiles.
And so the rule is?
N plus 2 and then squared.
Quantity and then plus 2.
Yes.
So
The sum of n plus 2.
Plus 2 and then squared.
So the sum of n plus 2 and squared, and then we graphed it, and I was okay with my other poopy graph. It took me about 20 minutes to be okay with it, and then Dr. Browning told me to get an actual graph paper. Which is what I wanted all along.
Yeah, I took it away from her and then I gave it back.
Yes.
So, the
Not-
shape, go ahead, Brandon. I'm sorry.
Just some of the other questions. It's not going to be proportional. You can look at our ratios. 1/9, it's not the same as 2 16ths.
Okay.
Also, you can tell, that it starts to curve a little bit, but of course we need a little more data to see it clearly.
Yeah.
Our artist. You can come this way.
This one or this one?
Finish the graph and then go to the rule function.
So with the graph, of course, all we're doing is using our table here, and so you guys can see that the n-axis here, which we know as the x-axis, is our pool number, and we're going, we're skipping. So for every two of those, we did going by ones as our scale. Our t-axis here, which is our y-axis, is our total number of tiles, and we're going up by twos, and just plotting the points. So we have a discrete graph here, and just like what Brandon said, it's kind of curving, and especially if you got a ruler or anything to try to trace it, it would not work. And of course, lastly, our function based on our information is t is equal to the sum of n plus 2 and squared. So t, of course, total number of tiles, and n is our pool number. So we determined that the total number of tiles we use
Is the pool number.
is the pool number, and added the sum of 2 to the pool number and squared that sum. In a sense.
We knew what we were saying.
Yeah.
We just didn't quite.
quite.
We kept saying it over and over and over, and then we would forget what we said, and then try to figure it out again. So we kept breaking up our sentences.
So what's the slope?
Our slope is not there.
It's not there?
No, there's not a
Why
constant
is
rate of
it
change.
Oh, not a constant rate of change.
Sorry, there's not a constant rate of change.
Okay, because
It's non-proportional.
It's not.
not.
It's not.
Because
Okay.
it's
not
because
linear.
it's non-linear.
Not
It's
linear.
non-proportional.
Could you find the slope between any 2 points?
You could.
But it wouldn't be
Good.
Could,
consistent.
but it wouldn't.
Wouldn't be consistent, so if you found the slope between the first 2 points and
It
then
would
the
be
slope
different
between
than
the
the
next 2
next,
points, it would not have the same
Right.
slope.
It would be different.
Okay.
Did you try this to see if eventually it ends up being like closer and closer and closer to each other on the slope? Did you try?
I did, I worked through 10, pool 10 on each of
Because I
those
never thought about that.
before I
To
gave
find
it to
between
y'all.
2 points and then start.
It does not, it's not closer and closer.
Okay.
I actually don't remember, but I think I would have noticed had it been closer and closer together, so I don't think it was.
And then we were last kind of because I had an issue with relationship on saying it's a relationship, because I feel that if we just came out saying we are finding the relationship between the pool number and the total number of tiles, I kind of felt that we were telling them what they had to think right up front with our scenario, and we were saying that we would change the sentence starter or the sentence statement to compare the number of the pool number to the total. Was that what we, something along those lines, without saying, you know, this is what you're doing no matter what. Do like a self-discovery, because I feel the relationship portion would have been, it's better suited for DE and
Kind of led you a little bit there.
yeah, pretty much for the self-discovery portion of it, and then when they got down here, it was like, oh, that is a good relationship, and this is where I'm gonna start. So that's why Dr. Brown
Yeah.
and I
That's why
said to do it towards the end, because y'all all said it for us, and everything.
Yeah, I did ask them to go last because of that discussion on relationships. So your thoughts on that? Should I have not used the word relationship?
Wait, nothing to read.
I don't understand, is it, what kind of yes or no question that is?
Did using the word relationship, did that lead you too much into what to do? Think so?
Because it automatically tells me that there is a connection, and sometimes there's not a connection.
Oh, that's a good point. That does imply that there is a relationship or a connection,
Spell versus the compare part of it.
and sometimes there's not.
There's no,
Mhm.
some reason no linear.
If there
There's not
is.
a linear relationship.
So Brandon was saying that some of them are linear and some of them aren't, and so we will have a linear relationship and then we will not have one, and so it's kind of that when it says relationship between, we're already setting them up that there's going to be one,
That's
period.
a good point. That's a
So
good
that's
point.
where my mentality came in. That was about it.
I've never seen it written a different way, but you can write your own textbook and maybe make a whole lot of money. Saying things differently,
You're asking me to write, that's what.
but,
Sometimes it depends on how much time you have to teach it.
that's true, that's true. So, thank you.
12 days.
Thank you. So, some of the groups did, F. Who did F? Okay, you want to quickly though, that we explain.
Do you want our bid sheet ready?
Yes, because you're probably, but wait, you have to come up here too. Because here's my problem.
Oh, wait.
I'm explaining my mistake, my
You
graph.
have,
Two groups did F, so I'll come up here.
This was my issue.
Yes.
And I still got permission and I still had a hard time with this. When it came to graphing the data, this is a ratio consisting of comparing two numbers. It is not a fraction, which is a number. So actually graphing this over here was difficult for because it's not a number. You graph the numbers on a number line, this is not a number. These are two separate numbers being compared.
And that's an important point. 1/8 there is not 1/8, which is a quantity. That is a ratio of two quantities, and that was totally freaking Brenda out.
Was, and so my poor little brain could not come up with these science people, let's turn this into a decimal. So the closest I could get was trying to come up with common denominator, and then of course we had, if you, where was it?
48. The five doesn't work.
Yes, whenever we had, because I had reduced it, trying to see if I could come up with a common denominator, and so I ended up with coming up with 4/5, and 4/5 would not become a common denominator with any of my other numbers. We came up with 48, and so whenever I try to graph it with my little numbers, then I'm trying to put it up here and figure out where can I, so I just gave up. Luckily, we ran out of time, so I'm gonna use that excuse instead. So, you can look at, they're pretty
I converted all mine to
decimals,
because
yeah,
I
see,
didn't
I
have any
did.
problems doing that.
I did.
It didn't bother me to convert.
These science people.
Go ahead. Did you get a roll, Clinton?
Y is equal to x squared over 4x plus 4.
Okay.
So the equation that we used earlier to find the pool tiles over the one for the pool border.
So is it linear?
No.
Is it proportional?
No.
Is it anything? Yeah.
Yes.
No, it's not.
Do you know anything?
No, it's not.
Do I know anything about it? I took it all the way to 5,000. So PD number is 5,000 just to see because I was trying to take it out to the next level to see if it was a consistent rate of change. And at 5,000 we've got 2,500, which is about the same here. But between 1 and 2 the rate is what was it? 205 thousandths. So the rate, I mean, it looked like it flattened out. So the question that one of the other groups asked just a moment ago, it looks like it might, but I don't know.
Okay. You mean the graph may go up like this and then start like that, like cases of the flu?
Well, I
kind of
think it's
problem?
almost like the other one where it comes down to, as it approaches 0, you're not really seeing very much change. As it goes up, I mean, it's almost infinitesimally, it's not going to change that much. It's going to be right at, what did we say earlier? 2,500s, it's going to stay right around there.
Okay.
I mean, the change is going to be so small, but.
Interesting problem, isn't it? Very interesting problem. I wanna look at these fractions, thank you for that. But look at this fraction, 1/8, that's pretty close to 0, isn't it? And as the fractions change, look at this last one, 25 over 24, that's greater than 1. So one would assume that these fractions would become more and more improper as they increased.
So we had even noted that as the water tiles for every stage increase, they increase at a greater rate than the border tiles did.
Okay.
So,
Yes, at 5,000 you get 25 million over 20,004. So,
Okay, thank you. So a very interesting problem, not one you would give probably to middle school, okay? But I wanted y'all to try it anyway. The last two are last three are kind of iffy for middle school, but I did get this out of a middle school book. So somebody's doing it, I guess. All right, thank y'all. Y'all did a great job on that. So, we did that, we did this, we did that. So we've talked about discrete and continuous. What's the difference in discrete and continuous?
Continuous data, you can have to, discrete data standalone.
Okay, she said, I don't know if y'all heard her, continuous data you connect, discrete data you do not connect. Why can you connect continuous data?
Because in continuous, well, I'm thinking in regards to what, Brenda said earlier, discrete data you will not have like half of anything, and continuous data you can. I know I'd asked you what would be an example, so you all said time, so you can have half of an hour, half of.
Perfect. So in discrete data, you cannot break that into fractional pieces, whereas continuous data, you can break it into smaller and smaller pieces like time, distance, that kind of thing. So we talked about curved or linear for a long time, proportional or non-proportional. We talked about that. So teacher talk here. Fine. So if an outsider had walked into the room before lunch, when y'all all kind of have sleep now, what would they have seen or heard? What if your principal had walked in this morning? What would he think, Chief? Brandon?
Maybe along the lines of depth and complexity in the conversation.
Okay. If they took the time to listen to the kids talk, yes.
Understand that it was getting a procedural concept as well as the words he used, conceptual.
Good. Good point. Brenda?
They would see students taking ownership of their learning.
Okay, because they're doing the public display. Good. Did she get yours?
No, I was gonna say chaos and they were playing.
Okay.
Is what most principals, they're walking by, they're gonna see you're playing.
Some principals, when they come into a classroom like y'all were in this morning, they would think that the kids have gone wild. And you are not in control anymore. So you're gonna have to train your teacher, your principal, to know what to expect in your classroom. Yes, ma'am. Elizabeth.
Some differentiation in the level of rigor of each of the problems.
I did purposefully differentiate the level of the questions. And for the last three, I really tried to get some high school people, you know, in there. And then the first one was so fast that I also gave it to some like third graders. You know, not that you're all third grade level, but you know, you had that third grade problem that you had worked first, and being the smart teacher that you are, you did it quickly, so then I said, okay, let's try this one too, because the others weren't through yet. So, Denise, you had your hand up? You forgot?
I was gonna say that he would have thought he was in a class of geniuses, genius third graders.
Yes, you guys could be. I can't wait to go see that show Gifted. I'm going on Sunday.
Oh yeah, that looks good.
Yeah. Yes, ma'am.
One thing that I know principals sometimes come in that might be a struggle is they'll come in and they'll ask a student, they'll walk up to the group and say, well, what are you learning about? I think at this stage, if anyone's like,